All right, we got properties of logarithmic functions today. Properties of logs. At the first, there's about 4 or 5 rules, and they're all not too hard at all. But the first one's called the product rule. Product rule says if you have a log with multiplication in it, you can split it up with addition. These work both ways. Also, if you're adding 2 logs, you never add 2 logs. You actually multiply the big numbers that are with the logs, and we'll look at that on the next slide. Right here, the first one says express as a sum of logs. And I have log base 3 of 9 times 27. What you can do there is you can say log base 3 of 9 plus, you can break up the multiplication with addition and make it log base 3 of 9 plus log base 3 of 27, break it up just like that. Now we know log base 3 of 9 is 2 because 3 squared is 9. We know log base 3 of 27 is 3 because 3 cubed is 27 and it's 5. Second part says express as a single log. Because they are added together, we can combine them by just doing the multiplication. So I'm going to put log p cubed q right there after the log. That's all you do. So if you have multiplication, you add. If you have addition, you multiply. Next rule, the power rule. If you have an exponent on a log, the exponent actually goes in the front. The exponent goes in the front. I should have said this a minute ago. All these laws are exponent rules, just kind of backwards, all right? So remember, logs are inverses of exponents, so the laws of exponent also, or properties of exponent work with logs too, because they're just inverses. So the exponent goes in the front, or if you have a number in the front, it's really the exponent on the log. They work both ways. All right, this is express each of the following as a product. So the first one, because the exponent is -3, the -3 goes in the front of the log, and you multiply the log by the exponent. The second one, this was supposed to be a square root of 7. I couldn't draw that on my, actually let's make it a fourth, it make it more interesting. Fourth root, which means that's the same thing. A fourth root is the same thing as 7 to the 1/4 power, which means that 1/4 is the exponent, which means it goes in the front of the log. It's multiplication. And part C, natural log e, base e, x to the 6th, the exponent goes in the front, so I can put the 6th in the front of natural log x. That's all you do. The exponent goes in the front. Or if there's a number in the front, it really represents the exponent on the log. The quotient rule. The quotient rule says if you have division, remember when it's multiplication, we added. So if you have division, you subtract. Also, if you're subtracting 2 logs, you're going to divide. Now, one thing I haven't made a big deal of either is the bases must be the same. And I haven't made a big deal about that today because they're going to give you the same base all day today that lets you practice the rules. But the only way the rules work is if you have the same base. Okay, this one says expressed as a difference of logs. And because there's division in here, I can write that like log base T8 minus log base TW. You just use subtraction. This is going the exact opposite. When there's subtraction, you can write it as 1 log by doing division. So I'm going to put 64 over 16. And everybody knows 64 divided by 16 is 4, so you can simplify it just a little bit and get down to 4. Very simple, really. All right, now they're going to give you a bunch of stuff in one thing. It says express each of the following in terms of the sums and differences of logs. So I want you to break these up. So the first one right here, first thing I see is I see multiplication and division. So I'm going to break up the multiplication. I see x squared and y to the 5th multiplied with each other. So I'm going to add those. Then I see a division sign, which means subtraction, and I'm going to put z to the 4th. Now the other thing I notice is they all have exponents. Remember, you can move the exponents into the front of the log, so I'm doing that also. 5 log y minus 4 log z. And that's all you can do on that one. All right, that's enough. That's quite a bit, but break it down as far as you possibly can. Okay, I'm going to erase that one and work on B. Hope you're ready for that. You can always rewind if you need to. Okay, part B, I basically have this right here, log base A, and I have all this stuff, a squared b c to the 5th, all to the 1/3 power because it's a cube root. So I'm going to go ahead and move the cube root to the front of the log, like that, and I still have this a squared b over c to the 5th. So now what I'm going to do is I'm going to put a 1/3 in the front, make a big bracket, and I'm going to simplify that as much as I can. So I'm going to have log a of a squared plus log a b minus log a c to the 5th. Hope you can read my writing there. All right, move it up a little bit. So I have more room. The exponents go in the front, log base a plus log base a b. Put the 5 in the front, log base a c. All right, now what I'm going to do is I'm going to multiply everything through by 1/3 just to simplify. Now, This right here, log base A of A, is really just 1 because a to the first power is 1. So I'm doing 1/3 times 2. 1/3 times log base AB minus 5/3 log base AC. That's a third. My marker's not showing up very well. And that's as far as you can go, which is far enough. Hope you get this 2/3 I did right here. Remember, log base A of A is 1, so it really did 1 times 2, and then did 2 times the 1/3. That's where that came from. All right, I'm going to erase that one. Let's get on this third one. You go back and watch it again if you need to. Third one has a lot of stuff in it also, as usual. So I got log base B A plus log base B y to the fifth. Did that because I have multiplication on the top. Minus, now I have two things on the bottom, so I'm going to, and they're multiplied together. So I'm going to put a bracket and write it this way because that minus sign needs to go for everything that's on my denominator. So I have this when I break it down a little bit, log base BA plus log, oops, that's an exponent. Need to fix that real quick. There's my eraser. There it is. Plus 5 log base BY. I'm going to distribute this minus sign through and put the exponents in the front. Minus 4 log n, and that's as far as I can go. And that's it. All right, one more of those. Going backwards this time, expressed as a single log. What I see, first of all, is I see a 5 in the front, which means it's the exponent on the x minus log base by. I'll see a 1/4 in the front, which means it's the exponent on the z. Remember, 1/4 power, bottom is the root, so it's really this. Sorry about that. So, because I have subtraction of the log y, that means it's going to be in my denominator. This is addition, that's positive. They go in my numerator, so I'm going to have x to the 5th on the 4th root of z all over y. Oh, something like a stray mark there over the y. And that's it right there, just one log. So combine all those logs by doing your properties. All right, should be the easiest property of the day, base to a power. Here's the deal. If they give you the base and a number, and they're the same number with an exponent, the answer is the exponent. Think about it, a to the x power equals a to the x. Remember how we do a log. So when I come down here and I see log base a of a to the 8th, it's just 8, because it's asking you a to what power is a to the 8th. The 8th power is. This next one, even though it's a natural log, the base, they don't ever write this, but the base is e. So they're asking you e to what power is e to the -7. -7. Two more slides. Or this is the last slide, sorry. This one, this also works backwards. If they give you an exponent with a log in the exponent, remember a log is the inverse of an exponent, but the bases are the same, it's just going to equal x. So on this first one down here where it says 4, log base 4, the 4s are the same of k, it's just k. If they give you e, natural log 5, remember natural log has base e, 5, the bases are the same, it's just 5. And that should make a little bit of sense to you because logs and exponents are inverse functions of each other. All right. Hope that wasn't too bad. Hope it wasn't that long. We'll work on it in class. Just make sure you have the properties down or the rules down. Really all you need. And same as exponent rules, pretty much. See you tomorrow.